I think everyone's joining in. Greeting everyone. My name is Hui. I'm from the Hertie School Data Science Lab. Welcome to our Meet the Data Scientist event series. I'm just gonna admit a few other people into the chat. So this is a series of talks on different topics of life, work, and research from contemporary data scientists. It's to give us a better understanding of where the industry is heading, as well as maybe some of the popular skills that is needed in order to be successful in this field, and maybe some of the challenges that are facing data professionals in our technology-driven societies today. And so we are very excited to have Alex Engler as our speaker for today's event. Alex is currently visiting Berlin as a researcher and also as a Fulbright-Schuman Innovation Scholar and Stiftung Mercator Senior Fellow. He's researching the overlap of data science and governance in Germany. And he previously worked as a senior data scientist in different organizations in the US, as well as he helped to run the Masters of Science in Computational Analysis and Public Policies in Chicago. And he also helped to design the Masters of Data Science in Public Policies at Georgetown as well. And for today, he will be talking about the ecosystems in Germany and the US that supports data science for the common goods. And he will be delivering his talk, and afterwards there will be some time for Q&A with the audience. So Alex, the floor is all yours.
Thanks so much for the intro. Hi, everybody. Excited to be here. I've been involved in programs like this for a while, and I think maybe the thing that I'm most proud of is the marginal impact of helping people who are passionate about data and policy to do good. In fact, really, I care about that much more than I care about any specific thing that I'm going to talk about. And I mean that really specifically, which is to say, if I say something that is interesting and valuable to you, a relatively small group on this call, I welcome you to interrupt at any point. Just talk, just unmute yourself and talk, and I will be happy to go down a little rabbit hole with you in that direction to the extent that it's generally valuable. That is just more important to me. So that was my first thought. I'm going to share some slides to talk about, and I should apologize a little bit because this probably isn't as much about the German ecosystem and the US ecosystem as I originally thought it was going to be, and a little bit more about just the data science and policy analysis ecosystem broadly, because that's easier to tie to things that I think are valuable to you all, and specifically stuff that is valuable for like what you do with your career. So I have two parts. One, what's going on in policy, and policy research especially, though a little bit in governments as well. And two, why does that matter for you as students? And I think hopefully I will draw a clear line between this sort of overview and really specific things that you should do in your career that will make you more competitive for jobs. So that's my goal. That being said, again, feel free to jump in and be like, hey, this is interesting and I want to hear more about this. I just got a great intro, so I'll just mention I've been doing this stuff for a while as a data scientist in government and in think tanks, as well as teaching it at Georgetown and at Chicago and Johns Hopkins. And these are the programs that I've worked with most. Chicago, which named its program Master of Science in Computational Analysis and Public Policy, because it was like right before the word data science got popularized. And then at Georgetown, the more recent Masters in Data Science for Public Policy, which shares the name of Hertie.
Alex, sorry, can you make the slide full screen?
Yeah, let's do that. Great.
Okay,
everyone see that okay?
Yes, everything looks
cool.
good.
Thanks. Okay, so a canonical points about data science in policy and otherwise, that it is not new. Alice Rivlin, who ran both the United States' Congressional Budget Office and Office of Management Budget, which are two big empirical think tanks, empirical agencies in the government, wrote a book in 1971 called Systemic Thinking for Social Action. And at the end, it is really about, this is the last sentence, put more simply, to do better, we must have a way of distinguishing better from worse. And she's talking about the methods and tools at that point that they're using. And I want to tie this really specifically to my talk, which is when we talk about data science in the context of public policy, it is absolutely a mistake to say all of this is new and that this is a brand new set of tools. And I think it's actually valuable to have in your head some of the history here, some of the this is new and valuable in this new way, and this has been around a long time, and it operates in its own slot of policy analysis. Most of the new things have not replaced the old things. In fact, we have new things that are doing new things and old things that are doing old things, and the overlap is still very, very muddled. The way that, for instance, machine learning is changing program evaluation so far is not very much, just a little bit at the margins. Okay, more tangibly, this means that I think it's valuable to have a definition or a working understanding of data science as an expansion, right? The term really means we've started to do more things. It doesn't mean we just started something. It means an expansion of what falls into our use of data. There's three things I bolded here in the top left. They have been around for a long time. Experiments, causal inference, microsimulations. I would also add descriptive statistics as survey methods. I would say somewhere in the realm of all of these from 40 to 70 years at least. Descriptive statistics even much further back than that. And so again, all of that's data viz. Really what we're talking about, or data science, when we talk about data science, though, often we're sort of meaning, oh, well, there's new stuff. We're sort of all encompassing. And here's a bunch of examples. So what I'm going to do is talk about some new and old of data science at policy institutions, and then zoom back out to why this matters for you all. I can't see your faces, which is okay. If you want to share your faces, you're welcome to. The other thing that I'm curious about is I don't know your backgrounds as well. So there are parts of this that could be completely known to, and you should feel free to chime in and say that. And there's parts that may be totally alien, and I welcome you to drop into chat or to raise your hand and say, okay, can you explain a little more? I'm a little bit guessing at where people all are in their sort of data science education. There's going to be some terminology I will try not to lean too hard on it. Okay, experiments. Just really quickly, experiments are still really valuable. They are still the gold standard of policy information. We care if public policy works. A really famous one from the United States, the state of Oregon decided to give out more Medicaid coverage. This is more free healthcare to low-income people. They realized they did not have enough money to do what they originally intended to do. And so they said, oh crap, we'll do a lottery and we'll give it to some people and not to other people randomly. This is a slightly insane thing for a state to do. It does not happen very often. But social scientists realized, hey, we can track the outcome of the people who randomly got Medicaid versus those who applied but didn't get it and see how it helped and how it didn't help. This is actually a random experiment, though many of you are probably familiar with quasi-experiments, where something that feels experimental but isn't quite also qualifies for this. And they followed these people over time, and it told us important things that Medicaid does improve health status, for instance, with levels of cholesterol and therefore diabetes later, but it doesn't actually make healthcare cheaper. It didn't reduce emergency services so much that things actually got cheaper in that sense. And maybe this doesn't matter here because everyone has healthcare, but it was a pretty big deal in the US, and this ended up being an incredibly impactful study. Experimentation, still hard because it's expensive and often unethical, but still the gold standard, hasn't gone anywhere, part of data science. Causal inference, especially around program evaluation. This is probably still to this day the most common type of data science. It is the most important part. It is the majority of empirical evidence in policy. And I think even if you want to be a data scientist, you're attracted to natural language processing and web data and machine learning, you have to understand this stuff. Typically data that was not meant for was not meant for whatever you're studying, but you find it, you observe changes over time, and you try to parse out causal inference, as in, did a specific policy change or intervention cause something else, rise in income and improvement in health outcomes, whatever it might be. The reason I mention this so explicitly is because, as I said before, we have a whole bunch of cool other new data sciencey things, and really none of them answer this question. Right? You shouldn't confuse the fact that we have all these new methods with that we've fundamentally changed our process of causal inference, where we care about if a change, specifically in policy analysis, a policy change caused something new. Now, if you follow, little treat for those who are super interested, if you follow the work of Susan Athey, she's a very famous economist in the United States, she is starting to push the boundaries of where these two things overlap, as there are other people, but most of the time, the vast majority of causal inference has so far not been substantially changed by data science, and those efforts remain new. There's no way to get like a quick poll. If anyone's listening and you know what microsimulations are, can you type just like the letter Y into chat, or just like yes? I think doing this affirmatively is fine. How many people here have understand what microsimulations are? I will wait as you. Nobody? And I see some no's. That's helpful. Hey, one yes. All right, cool. All right, I would actually expect the answer to be close to no one. And so that's not a critique of you all. It's just not a thing we talk about much. Microsimulations are rare, they are expensive, and they're incredibly valuable, and we put a lot of weight on them in the areas where they're used. You can think of a microsimulation as a program. It is not often very statistical. It is usually a very complicated set of rules. It's usually a very complex rules-based program that models something very complex. Typically, we use it with money. We use it where a specific change has a guaranteed outcome on money. And so we can change something and model what happens if we move this thing around, and we will see some effect. In the US, benefits policy, in almost all countries, tax policy. And there are other things that you can use microsimulations for, but those are the big ones. Often they're included in budgets too, and the budget outcomes of legislation. Sometimes more specific things to behavior. We do have health insurance models. The cost of Social Security often is the microsimulation. The phrase micro means they work on microdata, individual row level administrative data. And the simulation is that it's a guess. If we change this piece of tax policy, how much money do we get in? How much money do we lose? Also a really core part of data science, I would say, we use, every time in the US, a president has a tax plan, it goes through some microsimulation model and it gets wall-to-wall coverage in our press. Bernie Sanders' tax plan would cost this much money, versus Hillary Clinton's tax plan would get this much, Trump's did XYZ, right? These are really important. You probably won't read about them. They are very old. The original microsimulations were built on punch cards. It's the very beginning of computing. They are often 5 or 8 or 10,000 lines of code, and they're not learning processes. They are rules-based, just saying, if you change this tax policy, this person gets this much less or more money, and that has this effect overall on the national government. And so this is actually a lot. This is actually a huge amount of data stuff, right? I didn't even mention survey methods, right? Which totally counts in this too. And I feel like we should have this in our heads when we start talking about the rest of data science, the stuff that gets our attention, that has led in some ways to the creation of programs like yours and programs like the ones at Georgetown and at Chicago and other places, and have also that have brought this renewed attention. But it's important to recognize what's been here for a long time. Happy to stop there for just a second. Any questions on that? I just threw broad concepts at you, maybe some you've never heard of. Anyone want to chime in and be like, that was dumb, you're dumb, or like, that was useful and I have a follow-up?
Yeah, Alex, there are two
Yeah, please.
questions in the chat, but I think
Oh,
one
yeah.
to save for later, and one directly connected to this. Silvio asks, are not microsimulations similar to A/B testing?
Okay, that's A/B. The microsimulation testing is a really good point. In A/B testing, A/B testing is actually analogous to experimentation. So A/B testing, you actually give two different treatments, generally randomly, and you see how things change. Really common example of A/B testing would be, I am running a political campaign. I'm trying to get donations. So I send some people one email and other people another email. And then I look which of these two emails got me more money from these donors. And then maybe you repeat the process next time. A microsimulation, the stakes are way too big to do that. The stakes here are how much are people paying in taxes? You cannot randomize this at any meaningful scale. It's an enormous question. It has huge changes. You might update your tax laws every 15 years or something, right? It's too big of a change, and you can't do it randomly for some other. So it's entirely data-driven. So that's the difference between microsimulation and A/B testing. Programming languages for microsimulation, they're often written slowly, so they're often a generation behind. You'll find like some written in Fortran, some written in C++, some written in COBOL these days, and then hopefully the current generation is being written in R and Python and Julia, and that will be outdated by the time they're done. My God, Fortran. Say what you want about Fortran, it's fast. Your linear algebra libraries are written in Fortran, the ones you're still using. Quantitative data recommend. I'm going to come back to the administration question. I think that's a little too specific at the moment. I'm happy to come back to that in a little bit. And I see someone has their hand raised. You want to chime in?
Sure. Just a question. Specifically, I came from a social background, so I'm not exactly familiar with the technology language. But is this like a software or some kind of digital environment where you put some inputs and you observe the results, or it's like a statistical method? What's a microsimulation on itself?
Yeah. So you can just think of it as a parameterized program, a really, really complicated function. So the tax policy model in the US has 10,000 parameters you can change, 10,000 options you can change before you run it. One example of that is really simple. I'm going to take the amount of money that very high income people make, and I'll raise it by 5%. And then you run the whole model again, and you see how it changes the income distribution and how much money you get it. So it's really a function, but it's and as an individual user, you see it as a function with many, many options. But what it's really running is a simulation of the entirety of a nation's tax policy. Or again, we mentioned health insurance or something else.
Right. So this would be only specific. A microsimulation can only be designed for one country, one government, one specific at a time. You cannot simulate different results on different entities, I guess.
Yeah, there are people who've done it at the state level in the US, but even that was hard. And you still end up with essentially one model for each state. There's some of the codes reusable, but yeah, one at a time. Yep. Good question.
There's one more question from Ajit.
Please.
Do you also capture mental maps of individuals for microsimulations?
Mental maps of individuals? Hold on. Does that mean like, I'm in my head, I'm interpreting that as behavioral changes? And by behavioral changes, you can imagine coding. Yeah, great. So you can imagine coding in the idea that, as I just said, if you raise the marginal tax rate for wealthy people by 5%, you shouldn't necessarily assume that they work exactly the same amount or do the same thing with their income, right? You can imagine instead that if you did that enough, they would either work less or, as we've seen from wealthy people, put their income into a different form, right? To get more of it through capital gains or something else, or through business expenses. That is a big long-running conversation in the US. We have slowly started to implement behavioral changes, but the major answer is no, that there are very few behavioral adjustments in these models. And if you're saying like, wait, that makes them bad, you're completely right. If you make big enough changes in a microsimulation model that you foresee big changes in behavior, the models don't work anymore. In fact, the models have many flaws. The reason that they're valuable is because when you're talking about the scale of changes about messing with tax policy, the alternative to these is guessing, and guessing is definitely useless. So while these models are, this is a great example of all models are wrong, but some are useful. Microsimulation models, their intent is to give you a vague sense of change, better than a human guess, to which I think they succeed. But we haven't been able to make them better or much better with behavioral modeling. So only a little bit. It's a really good question. And if you follow up, I'm happy to send some resources on thinking about this. Okay, cool. All right, I'm happy to stop with more questions at any time, but that's a little wrap up of like what we've been doing. After this, I have like 30 examples of modern data sciencey stuff. This is too many, so I'm just going to mention like 2 sentences about each one, and I'm happy to come back to which are useful, and I'll point you to some resources to where you can find more. The big one, I'll start with machine learning. I love this example from Chicago. They realized they could predict the likelihood of lead paint, exposed lead paint, in the walls of houses. And then with that, you can send inspectors and prevent young children from getting sick from the lead paint chips. This is not a causal question. I don't care why there is lead paint. Couldn't care less, does not matter to me, right? It was painted when we used lead, who cares, right? Not the problem. The problem is, how do we prevent young kids from getting lead poisoning? And what you can do is you can use all sorts of data. You can use data that's about when the last time there was a renovation in the house. You can use data, when was the last time, how many rats are typically seen in the street. It doesn't matter. The point is that this stuff correlates with houses that are maybe a little more derelict, haven't been maintained as well, and there's some exposed lead paint from back when. And then you can send out inspectors. This dramatically raises the success of the inspectors, the likelihood of them to find a dangerous home. And you can even time it based on hospital data to when there are young children going back to that house. And so this is a different paradigm of thinking with data. It is a relatively new one, right? It uses data also not really meant for this, but to answer a different question to improve a government service. This has been slowly growing. In the US, you can look at 100 cases plus in a report called the Government by Algorithm report. So between Stanford and one of our government agency. And then in Germany, there's a smaller report, but it's, I think, still very interesting to some of you, from Fraunhofer, and it's KI in offentliche. I'd start using German. What a terrible mistake. AI in public administration, whatever that translates to. Glad we're recording this. Anywho, this is an example of totally expanded use of data science, very, very much new. We've sort of known we could do this for a while, but now we're seeing these really proliferate and really start to fundamentally affect government services. This is a big deal. You shouldn't confuse it with all of data science, but this really matters. And I'll talk a little bit later about how this affects the German context, right? What's happening in Germany that where there's sort of systemic buy-in to this. Another example, the first one was supervised machine learning. This is unsupervised machine learning, also changing how we think about policy analysis. Pew Research, which is a survey methods group in the US that has a data lab that does good work, decided that the idea of left and right, of liberal and conservative, did not fully represent the diversity of policy, of political views. So they surveyed a bunch of people, and then they did a clustering analysis. And clustering is the idea that with no specific outcome, you could find latent or hidden groups of people. They might not self-identify by this, but you can find groups that describe their behavior. And there are a series of methods that do this type of thing. Unsupervised learning is generally the umbrella category. And this is relatively new as well. This has not had a particularly large place in policy research and political science up until somewhat recently. Again, I'm glazing here a little bit for some of the history, but relatively new, lots of data, more opportunity to find some of these latent groups. And so Pew, their data lab, pushing the boundaries on how we describe politics. This is just a big data example. This is a very pretty chart from the Urban Institute where I used to work. But the actual story I want to tell here, because I'll come back to visualization in a second, this is just about more data. This is about how Americans hold debt. It is a very depressing graphic, almost all of it. It's real bad. But underlying this data is actually credit card level transactions. And there's two things that are interesting about that. The pure amount of data that credit agencies have is so large that it requires us to do new things. You cannot run analysis on this on R on your computer. You need to use parallel programming or distributed computing. You need to use the cloud or high performance server of some kind. It is just enough data. There is no way around it. And so, well, often, usually when people say, oh, big data doesn't mean anything, sometimes it does. Sometimes it means you need to use different software and different hardware. And that's the case here. And so we did this with Spark in the cloud, Spark being a distributed computing framework that's very useful, and made this go much faster than we would have been otherwise able to do, right? So I actually think the company did this, the credit agency did this, but the actual analysis, but again, the size of the data required a new framework to approaching it. Text as data. Lots of examples of this. I actually think you guys are going to hear about this as students, given that I know your professors work with text. So I'll just say one thing you can do with it is you can look at the overlap of types of jobs and patents, as in this example. I thought this was an interesting analysis, and what they said is, well, we can find lots of patents in certain areas for artificial intelligence that match job descriptions. And so we think that artificial intelligence is more likely to replace that type of job if we find more patents in that area that match certain job categories. I thought that was an interesting approach to natural language processing. There are flaws in this method like there are in everything else, but hey, text is data, right? We're still experimenting, and this is a big one, especially for anyone interested in political science, right? So the text data really becoming quite prolific. Network data. Maybe I'll not do two of these. This one is about disinformation. What they did here is they looked at the media outlets in the US and with how often they link to one another. So it's the amount of times they're viewed and seen is how big the circle is. And then how often they link to each other is their relationship. And what it shows you is over time is that the conservative news in the US has just like broken away. It's not that the middle has changed or the left has changed, it's that the right has moved further away from the center, which matches a lot of other empirical research in the US that our Republican Party is becoming farther right. Rather than partisanship, you have radicalization on one side, right? Backed by a lot of evidence, but in this case, by this network analysis. New data collection. This is actually a project to measure inflation just with web data. I know I'm going through these fast. Sorry, I'm happy to deliver the slides and let people dive into more. Inflation with web data. The current way we measure inflation is kind of nuts. We have some data pipelines, but we actually call a lot of companies and we say, how much does your chair cost today? I heard a story once where some of it's randomized. I heard a story once where someone actually went to a vending machine outside of like a fire station to like check how much the sodas were, right? The way we randomize and collect pricing data is consistent and it's very valuable. It's a little dated, and there are some efforts to incorporate and expand the amount of web data that we use to measure prices. The Billion Prices Project is just one example. It's been doing this for a while, and it just exclusively uses online data to measure price and thus to inflation. I think it is actually technically the official inflation metric of Argentina. Probably this stuff doesn't totally replace government official statistics, but we probably find some way to merge them together. And US agencies have been working on that overlap for a while. German example, I really like this one. This is from Florian Keusch, who's at University of Mannheim, and working to combine digital trace data. So the data that you get from devices that follow you around all day, in this case, cell phones, and using that to combine that with administrative data from agencies, sort of like in the example with prices, but this is a little more about stuff like mobility. People's mobility has been a big question in social science for a long time. Where do they go? How much do they walk? What are their commutes? Does their movement and distance correlate with job outcomes? Anything like that, right? And we haven't really been able to do that for a long time. Now we kind of can. The downside, this data, like many of the data sources I'm mentioning, is not necessarily representative. You have to have a smartphone, you have to get contacted by these surveys, you have to agree to participate in the survey. And so the first step is always, and this is largely the stage right now, how to actually learn from this data in a way that reflects your overall population. And so again, really interesting. I am absolutely convinced that we will have official statistics that include digital trace data like this. It's just a matter of when and how to carefully and consistently institute data pipelines. The representativeness is one challenge. I'll also mention that the willingness of private companies and individuals to allow this data access is another big challenge for understandable reasons. I'll skip CSET for now. That's cool. Satellite data is great. This is another now imagery. I did networks and text and web data. So one with imagery. There are lots of places in the world that don't have high resolution wealth data, especially in developing countries. It turns out you can do a pretty good job of guessing based on satellite imagery. So specifically in this case, what they're doing is they're taking satellite imagery of areas where they do have wealth metrics, making a predictive model that says when the roofs are made of this material and the road density is this dense and there are this many cars and this many people, that's about usually indicates this much income. And then they're applying that model to the areas where they don't have the income information, right? And then building a better than nothing estimate of economic welfare. This was piloted, I think, by Stanford. It is now just like part of what the world, this is like part of a World Bank project that does this as an ongoing way. Another really cool example is tracking deforestation with satellite data. And I think very clearly the best deforestation data now is from satellites. There's an example where it's even easier. Is there a tree here? Yes or no? Okay, cool. And the last one I'll mention is a changing, is this the last one? Am I a liar? Second to last one I'll mention is the changing approach to data visualization. I love data vid. I'm going to take a second to click on one of these, show you what I mean. The idea that graphs are new isn't really a thing. I think the percentage of the screen that they're getting is really what's changing. And you see this first in journalism and media, but you're seeing it more and more from research institutions where data is taking a higher percentage of the screen. And in fact, in many ways, as you can see here, the graph is actually staying while the text continues up. And what I really love about this, this is a prediction about a forecast of how prison populations change under different policies. You can click on different scenarios and the graph that are in the text, and then you will see those reflected in the graph. The Urban Institute, where I used to work, led by a team of data visualization people, led by a guy named Ben Chartoff, which is an excellent name to be a data visualization developer, have done this really, really well, and have this really excellent eye for storytelling with visualization. Where they sort of weave in the graph and the story. And so here's another example where you have an individual and they mark this individual with a blue dot. And then as you follow down and go through the graph, you can actually see that individual. This is about their commuting distance in DC, where I normally live. And you can watch that person continue across the graph and then continue on with some more data following the blue dot. And then they're going to switch people to a yellow dot. And then going to follow this person's commute across the city. And I just think they've gotten a lot better at weaving these stories together. We're going to tell a story with data, but we don't just want to show you a graph and then show you some text. We're going to sort of build this into a little bit more of an immersive and interactive feature. And I have some examples in this that I can share. Yeah, but more of that. So it's this while data viz is new, we're seeing this much more interactive experience and maybe immersive experience of storytelling with data. And the last one I'll mention, which is in some ways the least exciting, but man, can it be really important, is actually just data availability. So the example here is from also from the Urban Institute, the Education Data Explorer. And this is actually just an API, by which I mean the federal government has a whole bunch of data on education, as do the states, and their ability to consolidate that data and put it online has been not very good. And though the US government is getting better at making APIs and making data available, sometimes it is just necessary for someone else to do it. It's been a bad enough state for a long enough time that the Urban Institute collected this, made a consolidated place to get it, cleaned the data once really thoroughly so everyone can get to it, and then documented it and put this online. In this talk, I mentioned a whole bunch of examples where think tanks and policy research institutions were finding new ways to collect data. It's useful to think, if you're going to invest in this type of work and you're going to build a new data collection or consolidate data effectively, your analysis is one outcome, but another useful outcome is the data itself, right? If you're going to go through an elaborate process to collect a bunch of data, it's actually not such a bad idea to just make it available in addition to your analysis. And both of those things can play a meaningful public role in sort of from a data science perspective. And the Urban Data Explorer is a really good example of non-governmental API, though in governments they're also really important. So that is a range of new things I see both in methods and in data collection, maybe data collection being even the bigger change over time, and then the methods kind of being driven by that. And I can bring this to the German context, but let me again stop and see what people want to talk about and what questions you have.
Yes, we have one question from Ajit. I think it's also quite related to what you just mentioned regarding urban educations and urban institutions. He wants to ask if there's any suggestions for open data sources for academic research.
Yeah, it depends on that. That's too broad for me to answer usefully, honestly, but within specific areas of academia, the amount of public research is pretty high. So it's a little, so I think within an area I can probably help. I'm going to put my email address up, and you're welcome to email me with like, I'm looking for data sets on blank or in this field, and I will give you some pointers. Google, there's also a Google data set search now, which actually is interesting and might kind of work. But broadly, I think that's almost too, yeah, I don't think I could say anything useful on like how to broadly find data. But Googling is actually the #1 answer, followed by learning about the research institutions and data sources in your space, and then like FOIA is awful on it. Yeah, anyway, no, I'm sorry, a little too broad, but I'm happy to come back to it. Any other questions for the moment? Broader, expanded data science space. You're welcome to just unmute yourself and chime in.
Yeah, nothing at the moment, Alex.
Okay. All right, I'm happy to come back to this. So, all right, so what does this mean more specifically in Germany? a lot of what I just talked about was policy research, but that's going to be related. Germany has just announced a couple interesting things in broadly this space. There are a couple interesting points of history before this, but the most important is the online access law, because of the large number of services it's going to digitize. There was already some data for many of these services. Even if you fill out something on paper, it ends up in a database. But the amount of additional data you get when you digitize services gets much higher. It gets much easier to change and collect more data. You get much more user interaction data as well. And it also leads to more opportunities to automate processes when you already have a significantly online process. And so this is a big deal. And even if you don't consider yourself as someone who wants to do civic tech, like building services or development, this is going to create an enormously large amount of government data for which data scientists will be useful. On top of this, you have a new federal data strategy that came out in January 2021. And then written into the German part of the EU recovery bill is $240 million for data labs in every chancellery, and the chancellery in every ministry. It is not exactly clear what these are going to be yet, but it has to happen. They wrote it into there was a bit of a political sleight of hand to make sure that any governmental transition didn't affect this. And so writing into the EU recovery bill was actually pretty smart, and it will definitely happen here. And so they're all going to hire a chief data scientist and build something, it's not exactly clear what, that expands the data capacity of every ministry. And again, building on top of the sort of large number of digitized services. This also falls into the new coalition's agreement. The first section is titled Modern State, Digital Awakening and Innovation. It has various components, but one of them is making services better at the governmental level. Which sort of insinuates digitization and maybe even it uses the word proactive, which maybe in some senses you could interpret as a little machine learning-y, a little bringing services to people when they need it. And then you get an expanded number of civil society organizations. The one I've seen, I'm funded by Stiftung Mercator. They really care about this. Bertelsmann Stiftung and Stiftung Neue Verantwortung just both started data science teams. And Correlate has been doing this for a while and servicing nonprofit work with data science. But there's clearly, I think, a little bit of a civil society awakening and expansion into the sort of applied data science space. The other thing I didn't mention on here, some of these organizations that I mentioned Fraunhofer, I mentioned IFO, the contractors in Germany who've been doing data work for a while are also expanding their data science teams, somewhat analogously with the US. And there are headwinds to low government digital services use is a big one. Strong privacy concerns. I didn't mention hostility to algorithms specifically, but for anyone who followed what just happened in the Netherlands, in which a government was partially brought down by a poorly performing algorithm, that probably doesn't bode well for citizen trust in governmental algorithms. This was an algorithmic process that sort of punished people unnecessarily in terms of benefits. And then a decentralized government maybe slows this down as of limited ministry access to their data. So again, the German developments, there's a lot happening here. There are real structural barriers, but I think there's a fairly high amount of interest. I feel like there's a fairly high amount of political commitment. And so you could see an interesting expansion of the domestic capacity and work done. Though Germany is not exactly starting using data for the first time. It's been going for a while here. Okay, so that is an overview of how I see the field, how it's sort of evolving. This is the slide I started with, and a little bit about what's new in Germany. I want to show this to you a slightly different way, which is what's established versus what's emerging, and then I'm going to transition from here into what this means for you all. in terms of like getting jobs. So stuff that's been around for a while, proprietary statistical software. If you were doing the equivalent of this 10 years ago or 15 years ago, you'd be learning Stata or SAS and not R and Python. So we've moved from proprietary software to open source languages and tools. As a general rule, you should try to learn open source languages and tools every chance you get and avoid learning proprietary stuff. Unfortunately, governments and some research labs haven't caught up with this change yet, but as individuals, you will be dramatically benefited from investing in the open source side. R and Python being the most important, but there are other tools too. A big change, policy is predominantly public data, by which I mean created and collected by governments. In some ways, government data is not actually getting much better. It's getting incrementally better, whereas the amount of private data is getting dramatically better and dramatically larger. So learning to work with private data in some fields can be really important. I mentioned getting credit data from credit card companies. That's one example. All that satellite data is coming from private satellite companies with the little very small microsatellite fleets, or a lot of it is anyway. All the text data, much of the text data is coming from the web, right? Data visualization was here before, relatively static charts. Now we have this much more interactive and immersive side of it, also much more web driven, right? So far fewer PDFs, far more websites. And then in methods, I mentioned we had experimental design, causal inference, microsimulation, and relatively small data sets. Now we have machine learning and some cloud compute and sort of bigger data in all the ways that I discussed. So pretty big set of changes, right? And you can see how it's easy to confuse with like this data science with being like, it's just the stuff on the right, but really we should probably be using it to refer to all of this and just recognizing that we're going through a particularly fast transformation in what these methods are at the moment. Okay, so I mentioned this a couple times, but I actually just want to make sure it's clear that if you go into an interview at a lot of places that have been doing data for a while and you're like, hey, I'm here to bring you my data science skills, they're going to look at you like you're nuts. And you should be a little careful, even if you are really awesome at machine learning or really awesome at like text analysis or graph theory or whatever it is, just be respectful of the fact that there are probably data people in many of the institutions that you want jobs at that have been doing this work for 30 years. And they probably understand your field pretty well, like reasonably well, and have like valid criticisms of why those various new methods are not as useful in their circumstances. They may be overly skeptical and there may be value that you can add, but I would just be careful of that opinion. And you see this mistake like a lot. And so, you know, I'm here to replace the old process with a satellite data analysis is like very rarely going to go over super well for you. Being like, I'm excited to contribute and there are things on the margins that these new methods can do is like a little more likely to get you a successful job. It's also important to understand the old stuff, right? As I've mentioned, none of this replaces causal inference. So the extent to which you still need the old stuff. I always get really impressed when I meet someone who understands like microsimulation, because it shows a little bit of like respect for the existing institutions, which you need to know to sort of change stuff. So that's the first. Here's the second one. Sorry, this is too much text. I just mentioned way too much stuff for you to become an expert in 2 years or 3 or 5. That was dramatically too much material for you to become an expert at. So how do you approach this problem? I would choose a policy area and develop depth in that and let that choose your data and methods. I mentioned political science, networks and text are really common, international development, sensors and satellite imagery, whatever it is, you are, I think, much more likely to be qualified for employment having an overlap of domain knowledge in a specific policy subject and data science skills that match that than you are being a good general purpose data scientist. Probably the most important advice I can give you. And in sense, trying learn all this is going to screw you at some point anyway. It's just too much stuff. Related to this, one of the ways you can learn this is to execute on applied projects with real data. As students, every chance you get, you should execute on an applied project with real data. You should try to do the entire process from if collection's necessary, data collection, but if not, from data cleaning to analysis to presentation, make the whole thing look good and put it on GitHub. You should, and I basically mean never be doing like Kaggle competitions or just machine learning competitions or really narrow skill set stuff. I think it is almost always a bad idea in your situation, when instead you can be working on real data in your field. And I would also argue that being familiar with the important data sets in your area, if it's conflict and you don't understand the ACLED data set, I'm going to throw you out of the job interview, right? Really understanding the important data sets in your field is as core of a job skill in data science as understanding any individual method. In fact, it's probably more important most of the time. So for both of these reasons, one, because it'll pare down the methods to a useful set, and two, because understanding the data and the data practice is so important. I would really let your subject area choose what you learn to some extent for you. Finding and reading papers and what the cutting edge in that field is a great way to do this. And your resume can reflect all this. There's a way to talk about this in a fairly straightforward way. And so an example at the bottom, to the extent you can do this, including on class assignments, right, when you can, but certainly in internships or RIships, I accomplished a specific, meaningful outcome. First thing I think it should say, with a technical skill to sort of technical details. But in this case, trying to think of one from that's relatively accessible. Discovered spatial and spatial disparities in grocery store access using R's geospatial library, building a new spatial equity tool, something like that. But a tool and software package, programming language, often a specific one. I endorse putting specific libraries on your resume, but pairing it with a policy outcome. Every sentence you can write like this about a specific policy area is, I think, the absolute best thing you can do to advance your likelihood of getting a job in this space. And this is a little, this part's a little scary, but the more you can do this, you will be better qualified for fewer jobs, and that's a good thing. Having a ton of experience in just health and data science, taking the classes that are in that and learning the methods and knowing the data and doing an internship and doing an RAship, all in health and data science, you will be qualified for like 5 jobs, but you'll be like the best candidate for those 5 jobs, right? And I actually think that's a better and safer place to be in your career early on than being a pretty good, like the 3rd or 4th best choice for 100 jobs. I would rather be in the first situation than the second. So the more targeted you can get, I think the more qualified you will be to do specific stuff. You also have more control over where you end up. And again, learning everything, learning all of data science is probably impossible. I have a little more on some of the job roles that aren't data science, but I think this is the thing I wanted to end on. This is like the most important piece of advice that I have, and it sort of maybe is helpfully framed by the work I did. So again, I will stop and take questions, and if I'm also happy to talk about something else.
If you have any questions, you can just raise your hands and directly talk to the mic, or but I just want to echo what Alex mentioned regarding the domain knowledge with data science, because I think within the lab we also talk to a lot of industries and a lot of different companies, and I think the common theme that we heard a lot from different companies nowadays that the name of the game is no longer to be a generalist data scientist, right? So it's more about becoming a specialist in some field and having the data science skill to back that up. And that has been echoed by a lot of industry experts in different companies. And I think it's a very important point to spell it out, because I think a lot of people get stuck in this loop of learning so many different methods and so many different skill sets and trying to apply it all to NLP, to computer visions, and to all different kinds of new and fancy technologies. But then at the end of the day, it's also the industry, what kind of industry you're going for. It's important.
Yeah, it's too much stuff. It's become an incredibly diverse set of skills. I mean, there's some stuff that everyone should know, right? Depth in one programming language, Git and GitHub, the command line, some understanding of the cloud, right? Causal inference. There's some probably everyone should have some machine learning experience, but I know you guys are getting that. But after that, and even that far, it's sort of like, well, how do you weigh trade-offs between the 87,000 technical skills that there are? I don't know, right? Or without being guided by some sense of the policy area.
There's one question from Caroline. Do you have any advice on how to choose which policy area to focus on?
Yeah, that's like the hardest.
Yes.
Yeah, it's the hardest part. No, probably the thing you're most passionate about is a good guess. There are some areas in the overlap of data science and policy that are easier than others. So the first answer is definitely the thing you actually care about, right? Like in the field that you want to work in, by far and away the best choice. There are differences between them. There is a lot of health data. There is no shortage of doing health data sciencey work. Just the pure amount of health data that we collect and the sort of emerging field of precision medicine and the amount of sensor data makes health and data science kind of easy in the long run. You just know there's going to be a ton going on there. In the near term, data science and international relations and data science and foreign policy is a dicier bet. It is getting more empirical in fields like conflict studies. International development has been data sciencey for a long time. And one of the places I mentioned briefly, the Center for Security and Emerging Technology at Georgetown is sort of taking a very, very data sciencey look at foreign policy and doing a really good job there. But broadly, the number of jobs in data science and foreign policy is dicier. It's a little lower. That could change. Feels like it's on a bit of a brink, but there are some implications there. So broadly, I would say go with what you're passionate about. You might want to prepare a little bit for the fact that there are differences between the degree of data science focus in various fields.
Alex, I have a question that was based on a slide that you showed earlier. So I think one of the slides that you show is nowadays there are so many different ways to visualize the data, right? And also tell stories based on the data that you have and the results that you have from the data. And I think you show a couple of examples on how you can do that and making a very interactive data story. And so maybe you could give the audience some advice on maybe some of the technologies that is needed in order to learn how to create, for example, a data journalism article like that, or a dashboard that is interactive with people.
There's good news and bad news. The good news is the stack to do that is open source and free and accessible. The bad news is that it's hard to learn and you have to become kind of a front-end web developer. So in my little archetype of like job roles, the current state of doing data viz full-time is data visualization full-time is its own specialty, and you probably would have to just do that. It's to be the kind of person who can really build those consistently. The guy who invented the language that everybody invented D3, which is a JavaScript library for visualization. And it's really, really good and really impressive. And then that's why the New York Times hired him. They paired him with a designer named Amanda Cox, and the two of them went on to be the best data viz team in the world for quite some time. Mike Bostock has gone on to do other things now, but the reason that New York Times' data visualization is so insanely good is they hired the guy who invented the framework, and then paired him with a really truly designer, a truly excellent designer. And the upside of D3 is that it's incredibly expressive and you can make basically anything you want with it. And there's a billion code examples. But again, the downside is that it is hard to learn. If you really are passionate about data visualization, like not a passing interest, I would push you towards Scott Murray, Data Visualization for the Web. This book, Interactive Data Visualization for the Web by Scott Murray. There's the second edition, or maybe third edition now. And read it and make lots of things in D3. It's an uphill battle, but it's one of the most fun ways to, it's one of the most fun coding once you do it, once you learn how to do it.
Thank you,
The
Alex.
specific technical stack. And then like, if you're not going to do that, learn R and ggplot and some Adobe Illustrator, and you'll make really pretty static graphs. But the jump to the web development, it's like, it's a big jump.
Yeah, no, definitely. I very much agree with that, having to do some web development as well. Alex, is it possible that you can share your email address in case any of the audience have some questions later down the line?
Yep, I will do that in just a second. This is the last thing I wanted to mention. The two reports on how machine learning and algorithms are being used in government, these are really comprehensive. The first one for the US, the second one for Germany. And I mentioned a bunch of sort of good US institutions that just are really expanding how they're using data science. They have Medium posts, like a blog, right? You're not familiar with Medium. Data at Urban is the one for the Urban Institute. Pew Research is Decoded, are really good. And then Georgetown, this is the Center for Secure Emerging Tech. I think they're probably the most advanced policy research think tank ever. And I would encourage, and you can just like read their methods papers and you'll see they're doing a wide range of kind of incredible stuff. This isn't intro stuff. They are really invested. But some of their papers will show you where the sort of cutting edge of data science and foreign policy is. And then feel free to reach out. I would be more than happy to. Yeah, thanks to my funders. Also a professional lesson, always thank the people who give you money to survive. But I really do encourage you to ask questions now. I can stick around for a few minutes, or if you would rather not, you are welcome to send the questions over email.
Yes, I think Benedict want to ask if it's possible to share the slides.
Yep. Yeah. More than happy to share the slides.
Okay, and if there's no questions, then I think we can end the sessions here. And, so thank you very much again,
I will
Alex.
encourage questions one more time. If anyone, I'm slightly unsure. Normally I get more questions than this, so I'll just mention again that I would encourage you to just unmute yourself and ask. I have helped like a couple hundred people in your position like start this field and get jobs. So I might be useful. Just feel like I don't know. I talk too much. Very possible.
I have a question.
Yes, please. Thank you.
So I'm an MDS student at the Hertie School, and I was wondering, or I'm a bit concerned about finding internships in like the current state of like really starting to learn, and was wondering if you have like suggestions which positions or also institutions might be a good fit for the beginning.
Yeah, remind me, this would be for this coming summer, right?
Yes. Yeah. So after the first year.
Yeah. In some ways, and just to totally level with you, in a 2-year program, this is probably the hardest part. In some ways, I actually think getting a good internship in the summer can be harder than getting a decent job after graduating. And I mean that because by the time you're applying, you just haven't done that much yet. It's just a bit of an accelerated timeline. So first, it's understandable to be stressed. The good news is there are very few of these programs in Europe. There are only a handful of people doing this. And so you should, even though you haven't done that much yet, be somewhat competitive for data internships. I'm not going to be super useful on institutions. I'm starting to write about, I mentioned a few like Stiftung Mercator, like the Bertelsmann Stiftung group foundation that are both starting data science teams. And I would look at them. The thing I would do in terms of strengthening your ability to apply is in fact to try to do a couple, even if they're fairly straightforward, even if they're really early in your sort of set of skills, to do a couple self-directed projects. You have something you can point to. That is hard in your early period of classes, and it may not be possible yet, but I would say the sooner you can do even one or two things where you said, not only did I like go to these classes, but here is my demonstrated ability to do something. That is the way to make yourself competitive at the internship level. And interns, just to level with you, interns are infrequently very capable. It's just often like a little too early. And so if you can say like, here is a data analysis that I did from from start to analysis, look at it, here it is printed out, even if that's just one, that's going to make you, I think, relatively competitive. Again, within a policy area, do it on policy data with a goal in mind of specific institutions. If there is somewhere specifically you would like to work, looking at the type of work they're doing and then working on their data to execute on something is not a bad idea. Maybe slightly overthinking it, but that's not a terrible plan, right? Hey, they're working on this data, I can do an analysis using that.
Cool, thank you very much.
Yeah, sorry I'm not as up on European and German institutions. That I'm a little less useful for. I will say as a general idea, Twitter is also very useful. The data science and policy community are both on Twitter. Like they're two different communities, but they're on Twitter. And the extent to which if you find an institution that you might want to work for, I swear this sounds dumb, but go look at their Twitter, go see who works for them and what they're saying on Twitter. Those people will have like retweeted other data science and data analyses in their same field, and you will find other organizations that way. Actually, like Twitter is a really good tool to find your niche and to find who's working in it, because there's probably an established network of people retweeting one another's work. So if you find one institution that's interesting, Twitter to find others can be super, super valuable.
Steve Kerr also has questions on Python IDEs that are dominant in public policy research.
Is there a Python IDE that's dominant in any field? I am slightly partial to Jupyter notebooks, despite the fact that they are not the best coding environment for software. Jupyter notebooks have a strong value in their literate programming, which I didn't talk about much, but both are Markdown, and in Jupyter notebooks, you get effective use of literate programming, which lets you have your code and your text and your results all in one place. This saves you from a couple things. It saves you from recopying all your graphs into a Word document when your data changes. It saves you from screwing up versions and having versioning issues sometimes. So if you're in a role where you think your analysis might be shared, and you want to quickly go from code to communication, I'm a big fan of Jupyter notebooks and also R Markdown. If you're really building something that's closer to software or a development pipeline, then never mind. Then that's not what literate programming is for. But I'm a big fan of Jupyter notebooks and R Markdown in the policy space. I wouldn't call it dominant, but I would call it has a differentiating use. You're welcome. All right. Oh yeah, any other question? Okay, cool. Let's keep them coming. Also, if you guys have to run, I also realize it's like 6:10 on a weekday. So if you're just on here to be polite, please don't feel obligated to do that. Please ask away.
Thank you, Alex, for the webinar. It was very interesting. I have one question because you also work in the field of AI regulation and the ethic kind of perspective on that.
Yeah.
And I'm also very interested in technology policy in general and on a European scale.
Cool.
So I'm just wondering, okay, now I'm studying also data science for public policy. I have some coding background, but I don't see exactly, from my perspective as a student, how data science is applied in this kind of regulatory policy area.
Yeah, totally good bet. I think you will find at some point there will be a turning point from like no jobs to lots of jobs in this space. I would not be that worried about it. It's definitely an emerging role. You know, the most obvious thing in Europe is going to be if the DSA and the Digital Services Act, the Digital Markets Act, and the AI regulation pass. The AI regulation explicitly says you will need some amount of, you know, AI auditing and sort of data science regulatory capacity, both in existing agencies like the ones that are doing product safety work, as well as in agencies that oversee various tools that now use AI, like the ones that were overseeing the labor market or were overseeing finance, now need to have this sort of data science capacity. So if the AI Act passes, first of all, absolutely, it explicitly says we need, you know, that European countries, member states need AI regulatory capacity. I don't think that's the only way it happens. I'll give you the US case, which is a little bit different. In the US, we're probably not going to pass a big piece of AI legislation, but there is a slow emerging sense that regulation and the process by we regulate things needs to account for algorithms. We have guidance from the Food and Drug Administration and how they oversee medical devices that says, well, we actually need a new process here because the medical devices that have AI systems in them change over time. How do we regulate something that's learning and changing? Maybe a kind of related example, maybe we care more about physical devices that have autonomous systems in terms of their cybersecurity. I think it's fair to say we care more about the cybersecurity of an autonomous car than a human-driven car, right? And so there are areas where you can imagine more rigorous stress testing on AI systems as part of the regulatory process, like in those two examples, as well as sort of this evolution of human services around, say, hiring and finance. And in the US, we're seeing that incrementally, agencies just adding these rules and jobs over time and using their existing authority to regulate. In Europe, it could happen a little more all at once. But I think it's totally, you know, your ability to run an audit, to stress test an algorithm, to simulate what might happen if an algorithm learns in a certain way over time. I think those are going to be important regulatory skills, absolutely, and probably a big source of jobs for you guys at some point. Yeah, I'm super excited about that field. I think it's super interesting.
Thank you so much.
You're welcome.
Silvio also has some questions.
Okay, can you hear me?
Yeah.
Excellent. I am not a data scientist, so I didn't came into this discussion from a perspective of a data scientist or a programmer. I am more interested in practical applicabilities. Particularly, I am interested in using technology in the humanitarian sector, the deployment, and to what extent, my main question, and how do you see exactly the opportunity cost of engaging technology, and how would you address that from a perspective of a public policy, since every money that are not spent for the beneficiaries are money spent for something else. And the current system is that you would develop a project and then they invest into something, expertise or technology, hardware, and then after 3 years, everything gets unused, to say the least. How do you see this whole approach? How would you approach from a government perspective, and what kind of solution do you have for a long-term sustainable approach in this system?
Can you rephrase the beginning of it one more time? You're asking about, is this specific to an area of policy? And I just missed that.
Humanitarian emergency response.
Humanitarian.
The use of,
yeah.
For example, in a refugee camp, or distributing or cash transfers through digital currencies or anything related to that. That hardware and the software comes with a cost, which is an opportunity cost, those money not being used for the beneficiaries.
Yeah, no, I think that's totally fair.
What would be
I
your
should start
opinion on
by
that?
saying I'm not an expert in this, and this is probably not a good answer. In program evaluation, by which I mean the testing of whether or not interventions work, we spend a somewhat limited amount of money. There's sort of a rule of thumb that you spend only 5% on evaluation, right? And we frequently don't even do that. I think with data analysis and data science specifically, you could reasonably cap how much you think is you want to spend on that, right? Because you're right, none of what I'm talking about, or in rare cases, is what I'm talking about actually the service. And it's important to remember that data science should be in the service of better policy and should be in the service of better governmental administration or better direct action or better humanitarian efforts, as you're mentioning. And I think you're right that there is absolutely a cost trade-off. For a lot of this stuff, the amount of money you're talking about typically doesn't exceed 5%. When I talk about the data analysis, now, if you're saying that, you know, they're spending a ton of money on iPads to do data collection rather than actually giving people food or housing, I think that's a different, maybe a different question and a different criticism, but not necessarily a bad one. So within the very narrow slice, I know the amount of money we're talking about, I don't want to say it's insignificant, that's not true. But it's typically in that like 3 to 5% range, maybe. And then maybe whether or not you're buying technology for the people on the ground in humanitarian effort, that might be more money, but is also a trade-off I probably can't speak to. It's a little outside my expertise. That was not a very good answer. I apologize.
Yeah, sure. No, the suggestion I'm making as a remedial action is basically to develop the institutions you just mentioned as part of the government structures, and then donate man hours instead of money. So this way you have both the expertise and you have the long-term security for the kind of data scientist for 3 years. That would be difficult. If you have a career in a data science in a government, and then you're allocated to work, let's say 3 months on a project and another 3 months on a different project and so on and so forth, it would be making much more sense for the humanitarian system as far as I'm telling.
Yeah, that's interesting. I know that some of the larger humanitarian groups in the US have data science teams. Our FEMA does, our USAID does, that's the emergency response, and our aid organization respectively. Some of the larger nonprofits have toyed with building data science teams that things like try to optimize how you place out housing in a refugee camp, or where you place water access, I think was another big question. If you get to a large enough camp, that can turn out to be an algorithmic question. I think there is value in some of those things that is pretty specific. I wonder if organizations at that scale can afford just dedicated data science teams, but I'm not sure. Yeah.
Yeah, thank you.
Yeah, that's a good question. I wish I knew more about that. Also, a growing area of foreign policy and data is on the humanitarian response.
Yeah, so I think if there's no other questions, then you can always send an email to Alex or tweet him as well. Right? So
yeah, please do.
Yeah, so I think it comes to the end of our sessions. Thank you so very much, Alex, once again for a very enlightening talk, I think on a very interesting topics that is not often covered, I think, by the industries and experts. And so we're very sad that you're leaving Berlin for Brussels, but I'm sure that you'll be doing amazing things there as well. And this is also the last event for the Data Science Lab this year. And we will return in January next year with more news and events. And we wish everyone an amazing Advent season and a very Merry Christmas ahead. Thank you very much and have a fantastic day. Thank you once again, Alex, and everyone for coming.
Thanks, everybody.
Bye-bye.
Appreciate it, everyone. Have a good one.
Take care.